Thanks for joining today. This is the second session, one of 9, which we're giving over the summer. I'm going to do the introduction the same on each session. The reason for the session was meeting the training community and realising we had some real experts working for us, but some people who don't have a graphic arts background. So to try to fill that gap, we thought we would do these sessions to help regarding knowledge around colour and associated concepts and ideas. So we're on to session number 2 today. I'm just making sure that I'm actually on here. Yeah. 1, 2, 3. No, I'm not. Yeah, I am. Okay. Today's about colour appreciation. Is the second part of the agenda. We're going to have a look at the relationship between RGB and CMYK at a very basic level, and we're going to look at what we call grey balance. And this is, we can use this to correct an image. And in terms of correction, we're not talking about colour retouching in terms of making someone's eyes bluer or the lipstick redder. It's about colour balance. And it's important that we understand this so we understand what's coming in has a relationship to what we actually print on the way out. So part of this is going to be a presentation in PowerPoint, and part of it will be dropping into Photoshop, and all the samples of images we're using today will be available for you to download at the end of the session and for you to play with yourself. What does he say?
Bruce, we are seeing the presentation. We are seeing the presentation slide with 2 slides, not only the presentation.
You're seeing what? Sorry.
We see 2 windows. It's not only one window.
You see 2 windows.
Which windows do you see?
The one on the bottom, that one that you are moving the mouse.
This one.
Yeah. No, we are seeing 2 windows. That's what I mean. It's not the whole.
Okay.
The whole presentation on the screen. It's very slow. It's very small, and we can see very well.
Okay. Let's see if we can fix that. I don't know where to fix it. Because you 2 sit here, and I just pull this in.
Oh, yeah.
How's that, Carlo? Carlos? Hello?
That's better.
Good, great. Okay. So, one of the things I picked up on in a conversation I had whilst at Zycon is that often we walk into print shops and a printer picks up a piece of a print and he will be able to tell you without looking at a sample if it's good or bad, if they're happy or not. And part of today's presentation is to give you guys an insight into the mindset and to demystify some of the things they're looking for and looking at. So this is to help you sort of see there is some science, not just artistry behind printing. So let's not forget that we live in the real world with our eyes, and we're often faced against the reproductive world. So be that print or be that on a monitor, we have to follow our instincts, and that's one of the most important lessons here we're going to learn today. And we know when something instinctively looks wrong. And we're all colour specialists because we use our eyes every single day. And your subconscious will tell you when something looks natural or when it doesn't look natural. And we're going to use this idea of natural colour today. These visual defects we see are because the colours we see are not in balance. Now this is often called a colour cast, and it can be caused by many different things. It can be caused by the environment. In fact, sometimes our brains will trick us into seeing something that we want to see, even if we take a photograph and it will look actually different in the real world. It can also be caused by the device which is capturing that image. In the old days, this could be caused by film in the photographic process and the chemicals therein. But it still can be caused by electronic photographing devices and other image taking techniques. And also these colour casts can be caused by the print reproduction process, however that print reproduction is done. Hopefully you can see on the image on the left there's something wrong with it, but what? And on the right, I hope you agree, and I don't know how good the resolution or colour is, the image on the right looks more natural. But how is it fixed? Well, we're going to fix it using Isaac Newton and some things he found. So the biggest question is, other than some funky haircuts, what does Isaac Newton and Pink Floyd have in common? Well, Isaac Newton was the first person to understand the relationship between white light and the full spectrum. And Pink Floyd used this in their album cover in 1972. But this image, this iconic image of the white light and the spectrum, tells us something which we need to understand when we're appreciating colour. And that is, all colour is made from white light, and if we compress that colour back, we can make white. And a lack of colour equals black. So I now want you to take a thought experiment with me. Imagine you're looking at a piece of paper and you're sat in the room you are now with the lights on. You'll see a white piece of paper. If you turn the lights off, well, unless you've been eating lots of carrots, you'll probably see nothing. So you'll see black. And if we go somewhere in between, that paper will appear grey. So there's a lesson to be learnt here. And that lesson is that as long as colour is in balance, we will see grey. So when we see 100% of all colours, we see white. If the lights are off, we see no colour, we see black. And then we see, as long as those colours, the intensity of those colours are in the same proportions, we'll see a grey. And we can use this fact to help us appreciate how to correct images. What do we mean by grey? Well, we don't mean black and white. We mean parts of the natural world which, if we looked at it, would appear grey. So for example here, the engine components, the road, the sky or the metal wheel, these are all what we would describe as being grey. What do we know about these already? What should we know in the lesson so far? Is that these areas, if we were stood there in the real world, we're actually seeing equal components of white light, albeit at different intensities. So we're now going to apply this idea into reproduction. So we're going to start with our 8-bit RGB images. So as we all know, an RGB image is comprised of not every single colour in the spectrum, but 3 primary colours, red, green and blue. And as a pixel image, each pixel has a potential of containing any one of 256 shades, including 0. The first thing I want to point out is that RGB images, although do have a larger gamut than CMYK, are still a compromise compared to what we see in the real world. The larger colour shape we see there represents the full visual spectrum. So when we move to RGB, it's not a panacea. By far, it's a compromise. Because we now don't have a full spectrum, we used to have red, green and blue, our grey balance is comprised of just red, green and blue. So for our white light, we have 255, 255, 255. At black, 0, 0, 0, no light at all. And in the grey, we see an even balance. And in the information we've taken here from Photoshop, you'll see that although here the values aren't identical, they're very, very similar. And in fact, this is caused by the profile. So we can apply this knowledge to help us correct an image. Now through this presentation you'll see a little Photoshop logo appear at the bottom, and when you do, we're going to be using Photoshop any minute now. So again, I want you to use a thought experiment. So if we were seeing the motorbikes in the real world, we would see the grey road, but our digital image has for whatever reason, let us down. If we were to take a grey balance within that photograph, we would have an idea of where that image has let us down, where the colour inaccuracy is coming from. So let's move to Photoshop. For those of you who are not familiar with Photoshop, this is not meant to be a Photoshop masterclass. It's a tool to help us understand and to illustrate these sort of concepts. So we have in Photoshop a tool for taking a colour sample, and we have a tool to tell me what that information is. So I'm going to use my little grey balance man here. And in that value we see we get, and I hope you can see this, we get 153 red, 109 green and 126 blue. Now what we've learnt so far is that we know that grey should be even amounts of RGB, and we can use common sense to also see that the image is too red. So we're also going to use a tool now, it's called the curves, and we're just going to move to our red channel, and we see we have 153, and this is what we're going to put in as input, and we want to balance this, so possibly we're going to balance it to our blue channel, which is 1, 2, 6. And now the channel which is out of balance is green. And so we're looking for 109. And we want 1, 2, 6. So simply by looking at our imaginary little man here, we've managed to change scientifically a bad image to something that looks natural. And so this is not about imagery touching or making things look prettier. Of course, once we have things in balance, we can start to improve that image, but that is a subjective operation as opposed to understanding balance. So that's the first basic lesson in understanding how we can apply this idea of colour being in balance in the real world and applying that logic to images to help us balance those images out. Now, balance, the colour balance might not just be caused by a change in the different colours. It could be in fact that we have either too light or too dark an image, and this means that our centre point is not in balance. So we're going to look at a typical image which we see this, and this is often caused by under and overexposure. So here we have a dark image. Why do we know it's wrong? Well, instinctively we might think, well, it's at night time and it is a dark image, but the giveaway is that we've got a light sky. So something's wrong with the image. It also looks a little bit green, so it looks a little bit unnatural. There's something about it that's just not correct. So we're going to use a tool in Photoshop to first of all check that our if the image is if our center point is in the correct place. This is called the Levels tool, and we can see here that we've got a lot of pixel data at the from the halfway point to the black point, and we have very little pixel data between the half point and the white point. We can simply move where the center point is. Now again, this is a little bit subjective and maybe makes you feel a little bit uncomfortable as technicians, but I think straight away we can see that we're going to a more natural look and feel. We're also now going to apply the lesson we learnt with the first image and check our grey balance. So I'm going to check the concrete here in these on the floor. I'm going to take a sample here, and the sample is showing 153, 127 and 170. What I'm going to do is move the green and the blue to match the red. So again, it's just colour by numbers. We have 170 on the input, and we want 153 on the output. And the same for our blue. Here's 170 as well. And 153. So just to do a before and after, just using this concept of grey balance, just understanding the relationship between light, we've moved from this to this. Not being subjective, and you'll see now, yes, it is a dark time of day, and we're actually seeing the sunset actually occurring in the windows now. Again, you could do things to improve this image, but those would be subjective things like adding a little bit of saturation and maybe playing with the gamma. But at that point, we have a correct image. So that's how we work with a dark image. We can also use the same concept when we have a image which is too light. We can check our levels, and we can see straight away that we've no pixel data, no dark point here. So simply by moving this up, we make an improvement, but there's something still wrong. The balance is not quite correct. From the real world experience, I would imagine this bark on the tree to be more silver. So again, I'm going to make a pixel sample, and I'm just going to use that values to guide me to correcting the image. So I'm purposely covering the pretty girl's face up, but if we look at what we have on that bark, we have 63, 163, 167, but the deficiency seems to be in blue, so that's where we're going to go. And we want a 139 input, and to balance that with the rest of the colours, we're going 163. Now, just looking at the bark, that suddenly made our pretty girl look like she's a little bit more alive than suffering from jaundice. And so we're using colour balance, and one of the things we're learning here, hopefully, is that in the natural world we see colour imbalance, and we're used to seeing that when we look at pieces of print, which we're going to come to in a short while. Again, once you have everything in balance, you're welcome to subjectively retouch that, make it a little bit more punchy. But we are in the world of then colour retouching. Okay. But as we all know, we don't print RGB, we print CMYK. And I'm sure we are all familiar with the graphs, the diagrams we're seeing on the screen. And the theory is that our white light is now replaced by our white paper, and we're using inks as filters to give ourselves the colours that we would like to see. Now let's apply this to our grey balance concept. So we've already proven that this is pretty much correct in RGB. We have even values of RGB, and we can use that fact as a trick or as a tool to help us balance images. And so it would therefore be logical to think, if we look at our junior school physics diagram, that even values of CMY will also produce the same thing. However, it's not true in the real world. In fact, when we do produce even values of CMY, what we see is a warm brown result. You can measure the reason why, or you can deduce this logically, and the reason for that is the brown is caused by the dominance of red. And you could think of that as the reason the cyan is not strong enough. It can't be dominant enough to neutralize that colour. And when I went to school about this, it was to do with the fact that the pigments that we have on Earth are not compatible with the theory. And I think it would be, but I really don't have the science or explanation to explain why today in 2015 it's not possible. However, the cure for this visual effect is to reduce cyan and magenta, as we see in the graph. Now this gets us somewhere to a grey balance. However, it becomes too light. So let's welcome our friend black ink, and the black is set to key the image, hence CMYK, and if you've ever wondered why it's called K, it stands for key. So we now have what's called a grey ramp, and later on in these colour appreciation and summer schools, we'll see through colour management that we move away from this traditional way of thinking. But for now, this is a good way of thinking. What we learn is that there is a rule we can use for grey balance in colour images. Whereas with our RGB, we were looking for even amounts of RGB. In a grey image, we're now looking for around the same amounts of CMY and approximately 10% more cyan. So as you see, we're going back to Photoshop, and we're going to try to apply this technique. It's been corrected. Okay, am I bad? So I'm going to break the image to start with. So I'm going to use my sampling tool. I want my stone to be grey. And I can see here we've got 60, 23, 42. If you notice, I'm ignoring black because black is not going to change the colour. It's a supporting member in the cast of colours, and it's simply there to support the others in these greys. So we can see cyan is too high and magenta is too low. So we see cyan is 60. If we're going to balance this to the yellow, we're going to use our 10% rule. So 60 will become 50. And our yellow and magenta is too low, so we want our magenta to move from 23 to 40. So we now see a nice grey rock, and our lizard is looking more natural than he certainly did before. This technique, or this understanding, is key to understanding what is coming out of the back of our printing machines. When we see a cast on the printing page, then that cast is going to be caused not by black, but it's going to be caused by an imbalance of one of those three colours. And you can work this out by looking at the colour coming in and assessing what you're seeing on the page. It's a very, very good technique to use to look to greys to see if we're printing correctly. And this is what our customers are doing in their experience when looking at images. So we're going to However, there are going to be times where we have images which don't have or contain a grey. And I'd like to introduce you to an idea we call modelling, or you might think of this as shading. So if we take the green apple, if we were to draw this with pencils or paint it, we would probably do the shading we see with black. However, in CMYK, what we'll find, generally speaking, is the colour which will give the object a shape or shading is the tertiary colour. So in a green object you will find that's magenta, in a blue object you will find that's yellow, etc. And we can use this idea to again help us steer when we see something is wrong on a page. If we take flesh tones, for example, the main colour element of a flesh tone is magenta and yellow, and depending if they have a suntan or not, depends on the balance of the magentas and yellows. And the shading and the brownness of the skin is dictated with the cyan. Now again, we can use this idea to help us see, decide how to correct an image. So we have the pretty girl. Our first instinct might be that she looks too yellowy or too red. But when we take a look with our pipette and our info, we see that there's very, very little cyan in the skin. Now this is a little bit subjective, but luckily we have a real-time feedback, so we want to increase cyan, and as we do, hey presto, we see that our image goes from being very unnatural, but your instinct might be that it's too red. However, the reality is it wasn't blue enough. And it's this kind of information, this kind of knowledge, which is in our customers, the printer's mind. And it's that kind of instinctive knowledge he has when he's looking at those sheets of paper and saying it's good or it's bad. Now, as I said, I'm supplying all these images with the presentation for you all to have a play yourself. And there's a final one, which is a particularly difficult one, which I'll try to steer you through, because there's a lot wrong with this. First of all, it's out of balance. See straight away we can improve our image by making it in balance. Next, there's no real grey balance, so we're going to use our technique, and we're going to look for a grey in this image. Well, it may not be the street in this case, we can't rely on that. We can't rely on the building. So here's a clue. Paper tends to be white, so we're going to use our paper as a clue to where our grey should be. Again, we're going to use colour by numbers. So we see here that the sample in the paper is given as 166, 152, 149. So they're all very different. So we have to make a choice. Which way do we go? I think the image itself tends to be a little bit too warm, so I'm going to move towards our green to be our balance point. So I'm going to try to move everything to 152. So again, without being subjective, colour by numbers. What's our input value? What's our output value? And the same for blue. What's our input value? What's our output value? So we now have maybe a more natural looking scene. We're going to move to CMYK because we're going to print this thing, and then we're going to take a look at the main subject and see what we are getting in our flesh tones. Well, we're seeing magenta is a little bit out of balance to yellow. I think it's a hot day, so I think he's going to be a little bit warmer than he is. So by a few percent. And let's now look at what we've achieved. So in 1, 2, 3, 4 moves, we've gone from this image to this image, simply applying the logic of colour balance. If you want some other, my final little bit of advice, which has nothing to do with colour balance, but if you want to play with Photoshop, the final thing I would always do to an image is add a tiny little bit more saturation to make it look a little bit more alive, and use something called unsharp mask, which is an old technique which makes the image a little bit more aggressive, a little bit more contrasting. But that's a personal preference and nothing to do with colour balance. So just to show you, we've gone from here to here. So how can we apply this lesson today on our output? Well, let's not straight away now blame the machine if we see something wrong. Hopefully you can use these techniques to look at the artwork supplied and figure out if the artwork is incorrect. You can do this using your Gaudi browser or even upstream using tools in Acrobat or Photoshop. So if an image is coming out of your press and it's looking out of balance, it may well be out of balance. The flip side of that is if we have good artwork to start with or balanced images, very, very small changes in linearization will cause drifts and changes in colour. We are very, very susceptible of seeing changes in grey. And drifts are not affected by density, or not fixed by density. They need to be fixed by linearization. So just from a lesson I had the other week with a customer, it's so important that our customers are using and relinearizing their paper scripts. We can use visual references, and we've supplied now some these files you see are now on the CD of version 4 of the X800. These images are all in balance, and if we print them on a good printing condition, we can use that as a reference point when chasing down problems. So if your visual references are looking good on day one and we print something which is not looking so good, rather than have an argument with a customer or step in to try to fix something, print these files out in that printing condition to check to see if there is been a colour change. It may well be a problem somewhere else, and a lot of the time, because colour is so complicated and subjective, you need to remove all the possibilities before chasing down chasing the press. And finally, I wouldn't be doing my job as the guy who looks after colour management if I didn't try to promote a little bit about our Zycon colour control. We can reduce drifts by applying what we call smart separations. I did mention this in the first presentation, but in true to follow on, if we what we have is here a very imbalanced image. It's good. It's a good image, but very, very small changes in colour, in drift, will result in a very different printed process. So on the right hand side we have separations which are built through our profiling techniques, which are there to help reduce drifts. And we do this by moving colour away into the black plane as much as possible. And I'll just illustrate this for you. So on the left hand side, standard separations, right hand side the standard our cyclone colour control separations without black. If we introduce a theoretical kind of drift using Photoshop, so I'm increasing magenta, cyan, reducing magenta, playing with yellow, we see on the right hand side, left hand side, a big change. We still see a change on the right hand side, but if we flick between those two, before and after, it's minimized. So again, we can help our customers produce great artwork by employing colour management techniques. Thank you all. I've just put on the back of this my before and afters with the retouching, which you can all have a play with. I'm going to unmute you all and ask, are there any questions?